Took a look at graphing one equation and as an inequality, and we realized that by shading a certain region, we ended up with an infinite number of solutions that may or may not be on the line that you actually graphed. So today we're going to take another area and we're going to add a second line in and shade both the regions, and then the solution has to be correct for both of them. Okay? So I'm going to use the example at the top of the page to start with, keep in mind there. Okay, so for example, and we'll review yesterday, what am I supposed to do? Well, I have y is greater than or equal to x, and today we need to start looking at what we call the restrictions on it. Okay, so before I graph this, there are a number of ways in which they can write out the restrictions. They can say it's an element of all reals. They can say it's an integer. They can say it is a whole number. Or they can say it is an element of the natural numbers. Okay, so how does the graph of this differ from these three? Well, those three graphs are very specific to the whole number value. Whether, in this case, whether it's negative or positive. In this case, if it's a whole number, that means that you are only graphing in the first quadrant. And you're only going to graph it, shade it, and then you're going to only put the dots on the whole numbers, as opposed to shading all the regions, because partial answers are not allowed. This means the first quadrant again, but not equaling 0. Okay? We won't see very much of this guy right here. But we will see a lot. When we do questions, we'll see a lot of whole numbers. For example, they may take somebody's selling hot dogs and hamburgers for a certain amount of money, and they want to raise this much money, and they say, well, in order to sell that, we need to sell hot dogs for $2 a hot dog and hamburgers for $4 a hamburger, and I want to make sure that I have a profit greater than $1,000. Well, you can't have a partial hot dog. You can't have a partial hamburger when you sell it. So they're saying then only whole number answers are going to be useful for the question. Okay, so as we go through today, you'll see when we differ this a little bit. All right, and what it actually means to you. Okay, so first things first. What did we learn yesterday? How do I graph y is greater than or equal to x? What's the first step? Change it to an equality. So y is equal to x. Now I want to use one of my three methods in order to graph it. Which method do you suggest I use? Which one do you want to use here? What are the three methods? Y equals mx plus b. Is this in y equals mx plus b form? I think it is. Right? What's my m value? What is it? 1 over 1. That's the value in front of the x. What is my b value? 0, which means my starting point is 0 and 0. So I can do that as my method. Okay? So I go to 0 and 0, and where do I go?
Up 1, right 1.
Up 1, right 1. To there. Graph it. Solid or dotted line?
Solid.
Why?
Because it's equals to.
Because it's equals to, sure. Okay, so now what do I do after I've done all of that?
Figure out which side it should be.
Figure out which side is shaded, right? Okay, so how do I do that?
Pick a random coordinate.
Pick a random coordinate,
You can't do 0, 0.
and I can't do 0, 0 on this one. Remember what I said yesterday? Because it will be true because it's on the actual line, right? So let's pick a different coordinate.
1 and 2.
1 and 2. So here's 1, and that would be right there. So you're asking me to pick that coordinate, 1 and 2. Okay? So x is 1, y is 2. Is 2 greater than 1? So when I put this in, so I pick this coordinate here, 1 and 2. Put 2 in for y, 1 in for x. Is 2 greater than or equal to 1? Yeah? So then I shade up here. So that was yesterday's work. Right? Today they're going to add another line. The second line today is y is less than or equal to 4. My second graph, so it's all of this shaded area satisfies the first equation where y is greater than or equal to x. Now think about that for a second. Does that not make sense? That if it's greater than, it should be all the values above the line? Right? No matter what I pick here, it should be above that line. If it was less than that, then it would include everything down here, right? Okay, so now, how do I graph y is less than or equal to 4? What's the first thing I need to do? Change it to an equality. What does the line y equals 4 look like? What is it? Awesome. Where does it go through? 2, 3, and 4. That line is this line right here. There's the line y equals 4. It's a horizontal line. If it was x equals something, it would be straight up and straight down. Where is y less than or equal to 4 on this graph? Above or below that line? It's below that line, right? All my y values are down here, underneath this line. So I shade the area that includes both of them now. Now what have I done? Well, anything in this shaded region right here will make that guy true, and it will make that guy true. That's the difference today from yesterday. You have to now satisfy, the region has to satisfy 2 equations. Okay? All right, so let's do another one so we have a better idea. So maybe pull out some paper. Probably want to work on this. The first equation is x plus y is less than or equal to 5, where x and y are both integers. So remember what an integer is. An integer is a whole number, positive or negative. Minus 5, minus 4, minus 3, minus 2, no decimals. Okay, so I'm talking about whole numbers, including the negatives. All right. First step in graphing this is to do what? Change it into an equality. X plus y equals 5. Okay? Just because I used the y equals mx plus b on the last one, I'm going to do something different. Okay, I'm going to use my intercepts this time. So I'm going to create myself a little table. If I put 0 in for x, what does y equal? If I put 0 in for y, what does x equal? That was easy. Right? So now, one, 2, 3, 4, 5. 1, 2, 3, 4, 5. Dotted or a solid line? Solid because why? It includes it, it's equals to. All right, just thinking it through. I'm not sure, but I'm going to go with my gut instinct here. Do you think the shading is above or below the line? Because it's less than 5, right? So I'm suspecting that it's probably below the line. So what do I do to check and see if that's right? Put in a coordinate. Let's put in 0 and 0. 0 plus 0 is? 0. 0 less than 5? Yeah. Okay, so let's shade this area here. Okay, because it includes that 0, right? Okay. The next graph is x plus 3y is greater than 0. What's the first thing that I do? Change it to an equals to. How do you suppose we graph this? Okay, y equals mx plus b, so let's get the y by itself, so 3y is equal to minus x plus 0, right? Subtract x. What do I have to do next? Pardon me? Divide by 3. Y is equal to 1/3 x. Negative 1/3 x. Okay, so if I divide by 3 or times by 1/3, it means the same thing, right? So that's what I have. Okay, what's my b value in this equation? 0. So I start at 0. Where do I go from 0?
1 down.
1 down. Right 3. Solid or dotted? Dotted, no equals to, right? So this should connect here somehow, but whatever. Somewhere down here. Okay? Now, how do I decide which side I shade on?
Value.
Plug in a value. What value do you want to plug in?
1 and 1.
1 and 1, okay. So 1 and 1 is right here. Let's plug it in and see. 1 plus 3 times 1, what's 3 times 1? 3 plus 1 is? 4, is 4 greater than 0?
Yep.
Yeah, okay, so let's shade that then. So where's my solution? Somewhere in between these two guys right here. Just like that. There's my solution. So no matter what value I pick from inside this shaded region, it will make that true and that true in both cases. Okay? So I got a couple things though. I haven't done this entirely correct. Okay? And this is why we want to do this on graph paper, because it makes it inherently easier. It's a big word today. Big word. Not used correctly all the time, but it's big. Okay. Integers. What does that mean? It means I want to just put dots in on all of the integer spots. So instead of using shaded and scribbling it in, I just use dots on the regions. And that's because it's integers. It doesn't include anything that's shaded in between, because those are not integers, those are real numbers. So my graph, even though I drew all these lines in here, I want to put dots on there instead. Okay? We got that? There's one other thing I want to do that's going to be next in what we're doing here. And that is this. I want to find out where those two guys intersect. So I want to find out where those two lines intersect. So I'm going to use that in equation form and that in equation form, and I want to find out where they intersect. Okay, so I have x plus y is equal to 5, and x plus 3y is equal to 0. Okay? How do I find out where they intersect? Remember how to do any of this? Okay? Well, there's 3 ways in which you can do it. You can do substitution, you can do adding and subtracting. Remember this from last year? Okay? or you can graph them both, which we did, and you actually could locate it on your graph. If you did it on graph paper, you could find the point, provided it was whole numbers. Okay, so here's what I'm gonna do. I'm gonna do this quick, because it's not as essential as graphing is right now. Because I have 1x and 1x, I'm gonna subtract the two. So I'm gonna subtract, and make that a subtract. X subtract x is what?
0.
0. Y subtract 3y is?
Negative 2y.
Minus 2y. 5 subtract 0 is? 5. Y is equal to 5 over negative 2. Okay? It's yucky. Yucky way to start this. So now I'm going to put it back into that equation there. X plus, instead of y, I've got negative 5 over 2 is equal to 5. Add that to this side. X equals 5 plus 5 over 2. Common denominator. So where do those two intersect at? This coordinate right down here where they intersect at, 7.5 and negative 2.5. So eventually that's where we're leading. But for right now, I just need you to be able to shade the regions and find out the areas in which they shade. Okay? So using graph paper is going to be probably necessary for any of these right now. The graphing calculators also help, but we don't have enough for everybody, I don't think, yet. So until we can get that taken care of, we're not going to do that. Okay? That's all I have for today. That's enough to get you through 6.2 and 6.3. All right? And